There are two other higher order methods that we can call on our collections that basically run through and apply some operation to everything inside of the collection. In some ways, they're very similar to the operate on list and operate on array that we wrote in some of the earlier videos. And these methods are reduce and fold, and they actually come in different flavors: a reduce left, a reduce right, and a fold right. So if we have a collection like A, what reduce left does is, whereas all the other higher order methods we've looked at took a single argument, reduce left, or took a function that takes a single argument, reduce left takes a function that takes two arguments. And then it's going to call that function on the first argument and the second argument, and then it's going to take the result of that and pass that into the function to also apply to the third, and then pass that result in to also apply to the fourth. It's accumulating a value as it goes through the collection. And so one of the simplest examples we could give would be addition here, in which case it does nothing more than add up all the elements. Of course, we could have gotten that same value just by calling sum, but reduce left is more flexible in that we can do it with other methods, whatever it is that we want for combining the values that are there. To help you see what reduce left is doing, we could be more explicit about the function. We could call our values that are coming in A and B, and we will print out A and B, and then do something with them. It really doesn't matter. We could do the A plus B. So we're taking a sum again, but we're going to print out the arguments that are coming in at each step. So the first time that reduce left calls this function, it's 5 and 2, which you'll notice are the first two elements. And those get added together, and then that 7 gets passed as the first argument the next time. So we have 7 and 9, which adds up to 16, which gets called with the 3. And then that gives us 19, which is called with the 1, 20, which is called with the 8, etc., until we get to our final sum there. So hopefully this helps you to see what happens with a reduce left. If we do a reduce right, it works from the back end of the list, and the accumulator winds up being the second argument. So we had our 6 and 8, the last two elements, called in the order that they appear, and then those were passed, the sum of that was passed as the second argument with the 1, and then that sum was passed as the second argument with the 3, etc. Of course, because addition is commutative, it doesn't matter what order we do these in. However, had we changed this to subtraction, we'd get one answer if we do it from the left, and if I don't put on two t's there, and a very different answer if we do it from the right, because of the fact that subtraction is not commutative. The order in which we go through the collection matters. Fold is very similar to reduce, but it takes away some of the limitations of reduce. One of the things that happens with reduce is the two arguments both have to be of the type of our collection. So in this case, our collection is ints. The two arguments have to be ints, and the output has to be an int. And the reason for that is because, as we saw with reduce left, the first time that it's called, it's two values from the collection. So obviously both of those have to be ints. And the result of this is passed into the function the next time, therefore the result also has to be an int. So reduce left doesn't give us much flexibility as far as types go. We can get around that if we do a fold operation. Fold, like the fill, is a curried method, so it takes two separate argument lists. And the first one is the initial value for your accumulator. So if I'm doing addition, my initial value is 0, and then it takes the function that we want to use. So a fold with 0 and underscore plus underscore is basically what we did before, but the thing that we can do here is we can actually take and instead of a 0, I could pass in an empty string. And now we get the values concatenated together as a string. And to understand how this worked, it took the empty string and it did empty string plus 5, which just does string concatenation, so we got the string 5. Then we took that string 5 plus the integer 2, which gave us 5,2 as a string. And then it kept going and appending on other values. If we wanted these to be comma separated values, we could, though we'll get one extra thing at the end, but it's just interesting to see this. So I can make it so that each time it takes the accumulator and then the new number and then a comma. And that gives us a comma separated list, except for the fact that we always have a comma there at the end. You can also fold, instead of folding from the left to the right, you can call fold right and fold backwards across it. These methods, combined with the map and the filter, really do make it so that you can do just about anything that you want with just collections, that we don't have to have loops. We often won't need to use recursion. We can do the types of operations we want to solve the vast majority of problems just by calling these higher order methods.